Welcome to LIB Academy, and in this video we are going to look at commuting and non-commuting operators and why the need for us to know these operators. In our previous videos, we know that operators are some mathematical identity or that tells you to do something. Examples of them are the additions, the subtraction sign, the integration and differentiation sign, right, are all operators. And we do also have some operators in quantum mechanics. Examples are the Hamiltonian and then the momentum operator. So an operator works on a function called operand. Let's say we have our operator g dx squared operating on the function f of x. So in this case, our f of x becomes the operand, and this is our operator. So generally, if you have functions like this, let's say of this form, x, f of x, and then e, f of x, these coefficients here can be referred to as operators, right? Where these are operands. Well, let's look at what we want to do in this video. Commuting and non-commuting operators. If we have two operators, say operator 1 and then operator 2, and with a given function, we want to know if operator 1, sorry, before we continue, if we are giving two operations like this operating on a function, notice that the one closest, to the function, the one closer to the function will be operated on the function first. So in this case, this will operate on this, and the result will be operated on this, right? We want to know if this will be the same. We want to know whether the order of operation matters. In this case, we are operating operator 1 on the function first before operating, we are operating operator 2 on the function first, followed by operating the result on operator 1. And in this case, we are operating operator 1 on the function first before operator 2 on the result. So we want to know that this side here gives us the same result as this side right here. So if it gives us the same result, then we can say our operators do commute. So they are commuting operators. In this case, if they gives us the same result, if this side equal this side, then operator 1 and operator 2 do commute. We will soon look at the reason why we should know this. So before we continue, this is what you should know. And we'll look at the general definition for this. This is also part. Let's say we have operator A and operator B. We want to know if we operate this on the function f of x. Let's say we operate this on this, and let's say the result that we get is operator B s of x. And let's say we now operate A first on the function. Here you see we operate B first on the function before A. Here we are operating A first on the function before B. And this also gives us another result to be operator A h of x. So look at this. Here we operated B first followed by A. Here we operated A first followed by B. But the result is not the same. You see, operator B, the result here is operator B operating on S of x. And result here is operator A operating on h of x. S of x and then h of x or A h of x and B s of x are not the same. So these, we can say these operators do not commute. Do not commute, right? So now let's look at our general definition, and then we'll look at a work example before the reason why we should know this. So generally, we can say that the commuter, this is the definition, the commuter, the commutator A between operator A and operator B is defined as A cap B cap minus B cap A cap. So if you see something like this, it means that we will have the difference between A operating on B and B operating on A, right? So if A and B commute, then if A and B commute, if A and B commute, then A operated on B minus B operated on A should give us 0. Because we are saying that if you operate A on B, the result that we should get, let's say from here, if you operate operator 1 and operator 2 on the function, the result that we get from the left side should be equal to the right side. So if the left side is equal to the right side, then if we find the difference, definitely we are going to get 0, right? So if A and B do commute, then A operator B operator A, sorry, let's say if you operate B on the function first followed by A, if you find the difference between these, it will give us 0. And we know that this means that um, if we have the function here, it means that A operating first followed by B, and here to B operating first followed by A. Let's look at a work example. Let's say we have operator A to be d dx, and then operator B to be x, and then our function f of x equal x squared. We want to see whether these operators do commute. And then the rule is that A, whichever way, it should be the opposite of the other. So here dA operating on the f of x should be the same, right? So now we have our operator A to be derivative. So d dx, and our b to be x, and then our function to be x squared. So x squared should be equal to b is x, so x, and then a is d dx. We have d dx, and then our function, which is f of x, to be x squared. So now let's simplify this. What do we get for this? So this one, x multiplied by x squared, will give us x cubed, right? So we are actually going to find the derivative of x cubed here. And here, we are going to find the derivative of x squared multiplied by x. So the derivative of x cubed is, we multiply this by the power 3x, and the power reduced by 1, which will give us 2. And here we have x, derivative of x squared, we have 2 multiplied by x to the power 1. So at the end of the day, we are going to get 3x squared equal 2x. The result here is not the same as this. Therefore, our operator A and B do not commute. Why? Why do we need to know commuting and non-commuting operators? Well, every measurement that you make on quantum system can be represented by operators. That is the first thing you should know. And sometimes you might be wanting to simultaneously, to make, two different measurements simultaneously. So let's say if you are to make two different measurements simultaneously, let's say one of the measurements is represented by operator A and the other one is represented by operator B. Before you be able to make two measurements simultaneously, the measurement representing the two operators must commute. If they do commute, it means your measurement is kind of going to be possible. So this is what you should check if you want to make two measurements simultaneously on a quantum system. Well, you should know that in quantum mechanics, we are still making derivations, still working on the theory. A lot of scientists are still working on the theory to check improvement. So actually now no one understands, quantum mechanics. We are still working on them. But we do know they are useful to us, as stated by various scholars. So your takeaway, commuting operators and non-commuting operators. If we need this because sometimes you might want to make two measurements simultaneously. So if that is what you want to do, and then the operators representing the measurement, the two different measurements should commute before you can proceed, or before you can predict the possibility of your result. So that is it for this video. Kindly subscribe to this channel or like the video if you found it helpful. So see you in my next video. And don't forget, this video is part of a playlist, Quantum Mechanics. So you can feel free to check it out. Thank you.